Jai Hind everyone, my name is Mukulit Goel and I am Assistant Professor in Department of MCA. Today I am going to give a lecture on modules and packages in Python from the subject Python Programming, having subject code BMC 301, and my target students are MCA second year. So first of all I will start with one of the module or package in Python known as NumPy. Its full form is numerical Python and its basic use is for scientific computing. What do you mean by scientific computing? Basically, scientific computing is used for doing the mathematical calculations. So it contains basic linear algebra functions, Fourier transforms, random numbers, and it will also be useful in integrating C and C++ codes. And it is widely used package in terms of research, data analysis, and sometimes for the simulations and used in the machine learning applications also. So first of all, I will discuss NumPy in detail. So first is its key features. So it is the n-dimensional array, means it does not have, we can give the rows and columns, we can specify, but it can also use or allows the storage and fast manipulation of homogeneous data types across multiple dimensions, and the array consists of n dimension. So it is known as ND array, n dimension array. It provides optimized routine for mathematical operations. NumPy offers more efficient performance due to contiguous memory allocation, and it is also interoperable with other Python packages like Pandas for data analysis, scikit-learn for machine learning, matplotlib for plotting. So it is also interoperable with all other Python libraries. What is NumPy array? Basically, NumPy array is to facilitate advanced mathematical and other types of operations on large numbers of data. Such operations are executed more efficiently with less code, and is not a basically it's not a programming language. It is just an extension of Python. It is basically a module of Python through which we can work on homogeneous data, which works faster for due to contiguous memory allocation. So I will discuss it in detail, but before that I will compare this NumPy array with Python list. Basically, list have some foundations or limitations. So those limitations are element overhead, in which the Python list is not very feasible to use with large number of elements. Python list can hold different data types. The list may not store elements in contiguous memory allocation, due to which the memory fragmentation, which causes memory fragmentation, and also it will not work very efficiently with large elements. Its performance is normally it's not used for very fast processing. And while we talk about NumPy array, they works with the homogeneous data. It works with the data type, which reduces overhead by eliminating the need to store information of each element. They use contiguous memory, so it will reduce the memory fragmentation and allow for efficient and fast access, even used for the large number of elements. Through NumPy array, we can also give a size of a array, which is known as array metadata, and it is the fast performance array, which is optimized for large numerical computations. So what are the functions in NumPy? Basically, the functions in NumPy, first I will tell you how we should call the NumPy array. So for calling the NumPy array, we use import NumPy as NP. In my preceding slides, I will show you the how the NumPy, how do we code in NumPy. And before doing any coding, we should need to import the NumPy, and import NumPy as NP is defined, is declared. So we declare NumPy as NP. So when we use any function, we use NP before any function and the name of any function. So for array creations, these are the functions. So np.array, create an array from Python list or sequence. np.zeros, it fills an array with zeros. np.ones, filled an array with ones. np.arrange, create array with evenly spaced value within a line range. np.lin space, creates an array with evenly spaced number over a specified interval. Means if we need each alternate row with 1, so we use np.line space. So each alternate element in our array should be 1. So np.random.rand creates an array with random values. So these are the basic functions which we use in NumPy for array creation. Now for array manipulation, if we want to reshape our array, then we need to give a np.reshape. If we want to flatten our multi-dimensional array into 1D array, then we use np.flatten. If we transport the axis, for transposing the axis, we need np.transpose. For concatenating, we use np.concatenate, and for splitting, we use np.split. So these are the array manipulation functions, simple array manipulation functions which can directly use with the name. Now I will go into the NumPy statistical functions, because NumPy is used basically for mathematical computations or numerical computations. So if we want to take a mean of the series of a number, so we don't need to do anything, just we give np.mean. By giving the function name np.mean and the name of an array into that np.mean, will compute the arithmetic mean of all the array elements. If we want to find the median, we use np.median. If we want to find the values of standard deviation, then we use np.std. If we want to find out the variance, then np.variance. Find the minimum element, to find the minimum element min, to find the maximum element max. Peak to peak range is ptp, and qth percentile of the data, it's np.percentile. And compute the weighted average. For weighted average, we use np.average. Other than these, np.sum for compute sum of array elements. For multiplication means product, np.product. If we want to find the min or max along an axis, we use a min and a max. Then if we want to ignore all the not a number values, basically nan means not a number, so we use np.nanmean. Compute standard deviation ignoring not a number values, we use nan.std. And for variance ignoring nan values, we use nan.var. So nan mean, std and var is used for computing. By ignoring not a number values, we find out the mean, standard deviation and variance from the giving values in an array. So these are the statistical functions which we use directly by using the name of those functions or using the abbreviations of those functions using the NumPy. These are the NumPy functions for sorting and searching. np.sort, ndarray.sort, np.argsort, It is useful for indirect sorting and reordering another array based on the sort order. For lexical sorting, we use lexsort. For search sorted, means find the indices where elements should be inserted to maintain the order, useful for binary search insertion points. Now I will come to the program through which I will explain all those functions. So first write Python program to find the mean and median of a array, mean and median using NumPy from the elements in an array. So what we do, first we import NumPy as NP, then we give the define the elements in an array .np.array and give it name as data. So for first what we want to find, we want to find the mean value. So to find the mean value, what we do, we give it name mean underscore val is equal to np.mean, and np.mean from the which array, which is defined under the named data. So we give np.mean data, print mean underscore val. So with this statement, we will print the mean of this array. In the same way, if we want to print the median of this array, we give np.median data and print statement median underscore val. For standard deviation, we give np.std data. So through this, these are the simple ways of finding the mean, median and the standard deviation using NumPy. Now what if we want to find the mode of the given values? So we give an array, then we count its values, and then we mode is equal to argument of max counts. So through this we found the mode of this values, and the numpy.rgmax function returned indices of the maximum element of the array in a particular axis. So through NumPy we make the mathematical computations very easy. We do these mathematical calculations very easily without using any formula. We just give the names of those mathematical functions as the function in a NumPy and we find out the output. After NumPy, the next open source Python module which I want to discuss is SciPy. SciPy is an open source Python library used for scientific computation and technical computations like NumPy. It builds on NumPy by providing the wide collection of numerical algorithms and the high-level functions for tasks such as optimization, integration, statistics, image processing and differential equation and many more. SciPy has more advanced and specialized capabilities that are good for tracking scientific problems. So with the NumPy, we use another module, another library which we call as SciPy, means scientific Python. Basically SciPy is scientific Python and NumPy is numerical Python. So we combine both of these modules for doing the large computational mathematical problems. So the SciPy packages are optimize, integrate, linear algorithm, fast Fourier transforms. If we want to do any fast Fourier transforms on the data, then we use FFT, SciPy.FFT. By this we find the fast Fourier transform and find out the signal processing and frequency analysis. It is used there. So it is used there. So next is stats for statistical distributions and hypothesis testing. SciPy.signal is for signal processing functions and filtering. ND image, when we want to do a image processing on the multi-dimensional image. Then spatial is for mathematical functions like Bessel functions, gamma functions. So for this we use the module SciPy. The SciPy features consist of integration, optimization, linear algebra, interpolation, signal processing, image processing, statistics, spectral data structure and algorithms, like we work on the decision trees or k-neighbor functions, so we can use SciPy in that. Then special function which is used for the implementation of special numerical mathematical functions. So this is the program in which we use a linear algorithm and we use both the modules numpy and scipy. So first we import numpy as np, then we from scipy we import linear algorithm, or then we write the equation. It is a comment, basically the equation is comment, and in the array we give the values of a and b. Then we go in a solution. Solution means we give just line linear lin alg for doing the linear algorithmic functions for solving a and b, then save its values into x and y, and doing the matrix inversion, and we find the solution for x and y. So this is the output of this program. Means solution for xy is 2.2 or 0.42, in which determinant is -2, and the inverse matrix is -2, 1 and 1.5 and -0.5. The inverse matrix comes from this function. Inverse is equal to linear algorithm dot inverse matrix. So in INV is used for inversing a matrix. Next, third module which I will discuss is pandas. Pandas is basically used for data manipulation and analysis, and also for the cleaning of data. It provides flexible data structures and functions that make working with structured and time series data most efficient and intuitive. So in the pandas, the basic common, I must say, the common case study for studying pandas and how it used in time series data and the data analysis is predicting the stock value using real time series with the help of pandas. So this is the case study also which we taught to the students when we talk about data analysis, and the data is very much efficiently analyzed using pandas. So pandas is a powerful open source Python library designed for data manipulation, analysis and cleaning. It was created by Wes McKinney in 2008, and it's built in the top of NumPy, and also it integrates or interpolate with the NumPy. The name pandas come from the panel data and the Python data analysis. So basically pandas ka first part is panel data, and the DAS comes from the data analysis. So it consists of two data structures basically. One is series, which is a one-dimensional labeled array capable of holding data of any type, and next is data frame. It is a two-dimensional structure similar to a spreadsheet with rows and columns, allow complex data manipulation. So basically the work which we done through Excel is that work can also be done using the pandas. The analysis of that work is done using pandas using a data frame. So its features consist of data cleaning and transformation. So data cleaning and transformation means handling of the missing values, duplicate values and outliers. Next is the data aggregation and grouping, summarize or group large data set efficiently using group by. Data joining and merging, like we done similar in the databases using SQL joins. Then file handling supports basically all types of Excel formats, CSV, Excel, JSON and many more. And pandas is widely used in the data science, statistics and machine learning pipelines. It provides both high performance and ease of use for data set exploration, cleaning and preparation. For the preparation we need as a fundamental of model building and research. So its functions consist of, so like what we do in NumPy is import NumPy as NP. The same we do with the pandas, like import pandas as PD. We use import pandas as PD. So for core data structure functions, we use pd.series and pds.dataframe. We also use the short form of data frame, which is df. Then for input and output, we use read and to. For inspection, we use info, describe, shape, size and n dimensional. n dimensional for as ndim. For data selection and filtering is LOC and ILOC. For query, we use query. For data cleaning, if we want to remove all the element which is null, so we use is null. For non-values, we use drop NA. For replacing the values, we use replace. For remove all the rows and column, we use drop. For renaming, we use rename. For grouping, we use group by value underscore counts. And for statistical measures, same as we used in the NumPy, mean, sum, median, and STD for mean, sum, median, and standard deviation. For merging, we use merge. For concatenation, we use concat. And for replace, we use replace. And for extraction any value, we use str.extract. Str means string. End my lecture, in which I will describe 3 modules of Python, which are pandas, scipy, and numpy. So if I talk about the summary, then numpy is used for the mathematical functions, scipy is used for the scientific mathematical computations, and pandas is used for data analysis. So thank you very much.